Alright, this is Mr. Gillum, and today we're going to start talking about truth tables, and we're going to be looking at truth tables for conjunctions and disjunctions today, and then later on we're going to be looking at if-then statements with our truth tables, and it's going to get a little more complicated, so it's like an introduction to truth tables kind of deal right now. And what you're going to find is they're a lot like a Punnett square, if you've done Punnett squares in science class, where you match like the genes and you figure out what the chances are of having a trait. It's kind of like that, except for it's just with a conjunction or disjunction. All right, and basically a truth table just works like this. If I had a statement P, it could be either true or it could be false. If the statement is true, then not P would be false. And if the original statement was false, then not P would be true. Okay, and so you're going to use your reasoning skills to decide whether it should be true or false, regardless of what the statement is. You just need to determine right away if it's true or if it's false. A conjunction, or an and statement, and we'll say this is P and Q. If I were trying to find P and Q, I would start by labeling my columns as P, Q, and then P and Q. All right, and what I'm going to do is I'm strategically going to label my trues and falses in the first two columns because I want to make sure that I cover all of the different possibilities. So as I add conjunctions and disjunctions, my table is going to double in the number of columns. Okay, if you label the P, the conjunction, half of them true, half of them false, like I did right here. The first two true, the second two false, and then you alternate with Q, true, false, the whole time, you'll run into all of the possibilities. All right, you'll be sure to hit all of them. So I recommend that you do half trues, half falses in your P statement, and then every other one on your Q statement, and then you'll hit all of the different things that could happen. Now, if P is true and Q is true, then P and Q is true. That's the only time it's going to be true because we know that in an and statement, both P and Q must be true for the and statement to be true as well. So as soon as you see a false in either of these columns, a true or a false, they both have to be true for it to be true. So we would just fill it in false. False true would still be false. False false is false. For an and statement, it has to have both of them to be true. So in this case, if you want P and Q, only one outcome is going to get you that. It's if they're both true statements. All right. A disjunction or an or statement, P or Q. All right. And once again, I have one compound part, so I'm going to have 4 columns in my table. And when I look at it, like I said, I labeled the first half of my P's as trues, the second half falses, and then I alternated true, false on the Q column just so that I could hit every single combination. True, 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 false, true, false, false. There's 4 different things that could happen depending on my statement. So in an or statement, though, it's a little different. Okay, as long as one or the other is true, then I know my outcome will be true for my or statement. So there's a true, that's true. There's a true, so that must be true. There's a true, so that must be true. And finally, neither of these is true, so P or Q is not true, therefore the or statement is false. It's the only way you're going to get a false is if they're both false in an or statement. And we've been practicing that for a while now. We're talking about the truth value. And so down here at the bottom it says it shows the tables of the outcomes of the conditional. By labeling P half true and half false and labeling Q every other true false, all the possibilities we covered. And as we add conjunctions or disjunctions, the size of the table doubles. And that's going to be important. And I only have a couple examples in the notes today because we're going to practice a lot in class. And hopefully it'll be clear after just a few examples. All right, so we're just going to start fresh, and like I said, it doesn't really matter what the conditional is or what the statements are. We're just looking at the possibilities of truthfulness in each statement. So this time we got like a conjunction here. Actually, it's a disjunction here with a not P involved, a not statement. What I'm going to do actually, and I think I changed it on your notes, I want this guy to be, I'm going to put P and Q next to each other, and then we'll put not P right here. All right. And the reason I have so many columns on this one going sideways so many rows I should say, is because I need to know the truthfulness of P, I need to know the truthfulness of Q, I also need to know the truthfulness of not P. And then I also need to know the truthfulness of not P or Q. So you need to like individualize like every single little part. If you need to know something, you need to put it in there. So with the P's, I'm going to go ahead, the P statement, I'm going to say half true, half false. And with the Q's, I'm going to go every other one, true, false, true, false. Now when I look at not P, I know not P is the opposite of whatever P was. So if this P is true, then not P would be false. If P is true, it would be false. If P was false, it would be true. And if it was false, it would be true. So you can see like this basically always happens. If it's true here, it's false here, false, true. Not P just means it's opposite. Okay, so we got 3 of our labels done. Now I'm looking at not P or Q. So I'm looking at just these 2 columns really. Okay, and I just needed the P column just so I had some reference for my not P column. So since it's an OR statement, as long as one of them is true, then our outcome, our conditional, our disjunction would be true. Okay, there's a true there, so that is going to be true. This has no trues in it, so I know the OR statement is going to be false. There's a true there, and there's a true there. So as soon as I see that first true in an OR statement, I know that the disjunction is true as well. It'd be like saying lions live in the jungle or pink unicorns don't exist. So I mean, it just doesn't matter. Just as long as one of them is true, then it's an OR statement is, and then the disjunction is true. Okay, now I got this big one right here, and this is kind of what your homework's going to be like. I got one good example for you to watch, and then I'm going to let you loose on the homework. So when I look at these parts here, I see actually 2 compound parts here. I see an OR statement and I see an AND statement. And that's going to double the number of rows and columns that I have. Or actually the number of rows that I have. I'm going to 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I have 8 rows. I have two conjunctions or disjunctions, so I'm going to have 8 rows going up and down. If I had 3 conjunction or disjunction, I'd have to have 16 rows going up and down. I don't think they're going to get that complicated for you. But let's just take a look at it. I separated all the parts down. I needed a P part, a Q part, and R part. I needed a not Q part, okay? And then I wanted this compound part right here, and I wanted the whole thing is what I need to compare at the end. So for my P statement, I'm going to say half of the trues, half falses. And then Q, I'm going to alternate. Careful now, we have 3 variables. So what I'm going to do is actually I'm going to do half true, true, false, false, true, true, false, false. So half as many. So I did alternate still, but I did 2 trues, 2 false, 2 true, 2 false. And then finally, I'm going to go true, false, true, false, true, false, true, false. So the number of variables is going to help us decide the number of rows as well. More than just a conjunction, disjunction kind of deal. But as you can see, true, 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 false, true, false, true, true, false, false, all the different combinations of things that could happen are now listed there. Okay, so now I'm going to look and I'm going to see, okay, not Q. So I'm looking at the Q column. If this is true, then not Q would be false. True, false, false, true, false, true, false, that's true, that's false. If that's false, that's true, false, and true. So the not Q column is filled out. Now I have an AND statement here. It's AND statement, not Q and R. So now I'm looking at just these 2 columns. And since it's an AND statement, they both have to be true for the AND statement to be true. So I know I have a true there, and I also have a true there. But I don't see any other parts where it's just both trues. So therefore, since it's an AND statement, I know every other part has to be false. And then finally, I'm looking at my whole part, my part as a whole. So I can look at P or not Q and R. Okay, so P, so this column, let's use a different color so we can see it. P or not Q and R. So this is the last column here. And now we got an OR statement again. So we just need at least one of them to have a true. So true, false, since it's an OR and it has a true, we're going to say true. True, false, true, 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 false, true. Okay, so we got 4 trues right off the bat. Now we got a false, false, so that's false. We have to have at least one true. False, 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 true, so that's true, and then false, false again, false. So an interesting outcome here. We have 4 trues and 5 trues. 1, 2, 3, 4, 5, and 3 falses. So sometimes the outcomes don't think, they're not what you might think they are. So it's got a 5/8 chance of being true and a 3/8 chance of being false, just depending on which statement is true and which statement is false. And you're putting it square, or not you're putting it square, in your conditional statements. So there you go. That's how truth tables work, and I'll be excited to see how you do on these in class today. So that's all for today.